Hello, today we're going to be looking at geometric sequences. Remember, in a geometric sequence, you multiply to get from one number to the next, and that number you multiply by to get from one number to the next is called the common ratio, or R. This is probably going to seem somewhat familiar because we've looked at arithmetic sequences and the arithmetic sequence formula before. Now we're just looking at the geometric version. Some things look pretty similar, but the key difference is we have a times R here, and then n minus 1 is up in the exponent, which helps things shake out the way they need to because we're dealing with multiplication. So, most of what we're going to be doing today is we're going to be given some sort of information and we want to write our explicit formula, which just like we did with arithmetic sequences, we are just going to fill in A1, and instead of the common difference, we're going to fill in R. If we have A1 and R filled into the explicit formula, we can then use that to find any term number we want. So that's what we're going to focus on for the 6 problems I have up here, and then we're going to do 2 more problems where I show you how to find a missing term, a random term. So, some of these, they've given us straight up what we need. Others, we need to do a little work first. For the first 2, they want us to find the explicit formula. They've straight up given us the 2 things we need, A1 and R, so we just need to put those in the right places in the explicit formula. Explicit formula is going to be an equals my A1 number, which is 2, times my R number, which is 3, and then n minus 1 up in the exponent. That's all I need to do there is fill in the explicit formula with the correct information. The next one, same idea. They've given us A1, they've given us R. -4 goes in the A1 spot, +4 goes in the R spot, and then n minus 1 up in the exponent. Okay, so then from here, the rest of these, we have to either look at things a little more carefully or do a little bit of work in order to get A1 or R or both. What we've done in the next 2 is they've given us the beginning of the sequence. So the sequence here is -16, -8, -4, -2. We know that A1 is the first term we see, so A1 here is going to be -16, nothing crazy there. R is what we multiply by to get from one term to the next. Notice that our numbers are getting closer to 0, which means we are multiplying by a fraction. It looks like we're dividing, but remember dividing is the same as multiplying by a fraction. If you're having a hard time seeing what that fraction is, you can do that trick I showed you before. Take the second term and divide it by the first term. So -8 divided by -16, if you reduce that, is +1/2. And then to double check, -16 times 1/2 gives you -8, and then it checks out for the other numbers as well. So our R is going to be 1/2. So now we just take A1 and our R and plug them into our sequence formula. So our formula is going to be AN equals our A1, which is -16, times R is 1/2. Whenever your R is negative or a fraction, it's a good idea to put in parentheses to make things easier to read. And then n minus 1 up in the exponent. Same idea here. A1, we can tell what it is because it's the first number in the sequence. How do we get from one term to the next? My signs are going back and forth between negative and positive, so my R is going to be a negative number. To get from 2 to -10, I multiply by -5. -10 times 5 gives me 50. 50 times -5 gives me 250, so it all checks out. Put things where they go in the formula. So AN equals my A1 number, which is 2, times my R number, I'm going to put it in parentheses since it's negative, -5, to the n minus 1 power. The next 2 look like the first 2, except they didn't give us A1, they gave us A something else. We're going to have to work backwards to find A1, sort of like we did with some of the arithmetic sequences. So R they've given us, that's easy enough. They gave us A3. The 3 here is going to be n, and then the number you see after this equal sign we're going to put in the AN spot. So AN is going to be -54. I'm going to take AN, R, and n and plug them in my formula, which will give me everything I need to find A1. So I'm going to write the formula just so we see it a little easier. AN is -54. A1 we don't know. R is negative 1/3. And then since this is A3, N is 3, and then minus 1 is part of the formula. Simplify your exponent first. 3 times 1 is 2. And then you need to actually do this number to the power. Negative 1/3 squared is negative 1/3 times negative 1/3, so positive 1/9. To get A1 by itself, with A1 times 1/9, to undo times 1/9, I divide both sides by 1/9. And when I do that, I get that A1 equals negative 486. I used a calculator for that. Feel free to use a calculator, Desmos, when you do this on your own. They didn't just ask us to find A1, they want us to write the whole formula. So we have everything we need, we just need to write it out. So my final answer is going to be my formula with A1 and R filled in. AN equals that A1 I just found, negative 46, times my R, negative 1/3, to the n minus 1 power. Let's try another one like that. So same boat, since this is a 4 here, n is going to equal 4, and the number it's equal to, 108, is going to go in the AN spot. So, AN is 108, like I said. A1 we don't know. R this time is 3. N is 4, so 4 minus 1. Simplify your exponent. 4 minus 1 is 3, so we get a 3 power there. Do the exponent. 3 to the third is 3 times 3 times 3, which is 27. And then to get A1 by itself, I undo multiplying by 27 by dividing by 27. 108 divided by 27 is 4. So then write your formula. AN equals the A1 we just found, which is 4, times R, which is 3, to the n minus 1 power. Like I said, we're going to do 2 more where the goal is not to find the formula. The goal is to find a specific term. So I'm going to get these out of our way so you can see how that works. So what they're going to give you this time is they're going to give you the first term, or A1. They're going to give you the ratio, and they're asking you to find A something. In this case, A12. And I'll go ahead and write out the next one so we're ready for it when we get there. Okay, so they've given us the first term, they've given us R, they want us to find A12. We're going to use our formula. So since we're trying to find A12, instead of AN, I'm going to put A12. A1 is 3, R is negative 3, and then since this is a 12 here, N is going to be 12. So we're thinking 12 minus 1 up in the exponent. You can do this all in Desmos at once as long as you simplify this exponent first, which is not hard to do. 12 minus 1 is 11. If you don't, otherwise you have to figure about using parentheses in Desmos. From here, I would recommend putting this in Desmos or whatever calculator you are using. You're going to get kind of a large looking number, and that's okay. Because when we use exponents, especially higher powers of exponents, numbers get pretty big pretty quickly. So your final answer here should be 531,441. Seems really, really big, but we're multiplying by negative 3 11 times, which gets pretty big pretty quickly. And the negative part makes sense because our signs are going to go back and forth between negative and positive. Let's try another one. So A1 is 4, R is 2, they want us to find A11. So N is going to equal 11. Since we're finding A11, we write A11 equals A1 is 4, R is 2. Instead of N minus 1, we're going to put 11 minus 1. Before you put that in Desmos, I would recommend doing the exponent. So 11 minus 1 is 10. Simplify that exponent first. From here, you can type this into Desmos. You get a fairly large answer once again. When you do that, you get 4,096. That is it for today. If you are asked to write the explicit formula, remember to fill in A1 and R, leave everything else the same. If you're finding a term number, your answer will be a number, just like we saw in this last two. Have a great day.